Good afternoon, good morning, ladies and gentlemen. Welcome to another series of tutorials with me, Aubrey. This is going to be a very interesting lesson. Now, in this lesson, I have provided this solution and I'm just going to go step by step in how I was working out the problem, because I figured that if I were to solve this in a video, it would take too much time, so I just pre-worked the solution. Then I will be explaining what I was doing so that you will be able to follow through as well. So now the question reads, prove that x minus y plus y is equals to I times theta is equal to this if x cos theta is if x is cos theta plus I sin theta and y is cos phi plus I sin phi. All right, prove that x minus y over x plus y is equals to I tan theta minus phi over 2 if cos theta, if x is equals to cos theta plus I sin theta and y is cos phi plus I sin phi. So how we start off, I started off by picking a side that I'm going to prove, and I essentially picked the left hand side to come up with the right hand side. So I need to use the left hand side to come out, or let me say I'll use the left hand side to produce the right hand side. So as I did, I picked x minus y over x plus y, which is this part. I replaced wherever there is x, I had replaced with this part, which is x cos theta plus I sin theta, minus, which is this minus y, and y is cos phi plus I sin phi. Then from here, what do we do? From here, we expanded the brackets. So and grouped the like terms. So this is cos theta and minus sine cos phi plus I, which is the imaginary part, sin theta minus sine phi. And same with the denominator, cos theta plus cos phi plus I sin theta, and so on and so forth. So this is what we did to the denominator. Then from here we conjugate the denominator and multiply on top and at the bottom with the fraction we get. Okay, so this should be a comma. So we are going to conjugate the denominator, which is introducing a similar term but with a negative or the opposite of its imaginary part. So if it is positive, you introduce a negative, just like we did right here. So this is the conjugate of this, which is this in blue, as you can see. Then from there we expand. How we expand? We multiply cos this whole thing, cos theta minus cos phi, times everything here. Okay, same applies to I sin theta minus sine phi multiplied with everything there. We do the same thing with the denominator. All right, the simplification of the numerator, we see that we are going to have cos squared theta minus cos squared phi plus sine squared theta minus sine squared phi, that is plus I 2 cos theta sine cos phi sine theta. Let me just do this. It should be an I there. I forgot an I. Okay. All right. So that is what is there. So yeah. So we are going to have this. Then we are going to have this imaginary part, which is I 2 cos phi sine theta minus 2I sine theta, sine phi cos theta. Okay, and at the bottom part, what you should know is that when you are multiplying a conjugate at the bottom part, when you are multiplying a term with its conjugate, you just get the real part, you square it, and the imaginary part just like we did here. So we just get this part, we square it, and the imaginary part, we square it, and that is what you get at the bottom. No need to start proving yourself. So when you're multiplying a term by its conjugate, you get that result there. Actually, it's a property. So let me just say, if you have z times z bar, you get the real part squared plus the imaginary part squared. So that is a property you should take note of. All right, so from here, what do we do? From here we said, all right, so from here we grouped those with thetas. So we have cos squared theta plus sine squared theta. We had put here cos squared theta plus sine squared theta minus. So we factor out the minus. We see that cos squared phi has a minus and sine squared phi has a minus. So we factor out the minus. We'll have that, okay? And here we factor out the common terms, which is 2i, and we're going to remain with that. Then from here, we know that cos squared theta plus sine squared theta is 1, all right? And sine squared phi plus cos squared phi is also 1. Then here we know that cos phi sine theta minus cos theta sine phi is equals to sine theta minus phi. We know that. These are some identities. We know that the same thing for this part. All right. So when we simplify everything, here we are going to have 1, which is this one here. All right. Here we're going to have 1, which is this one here, plus I2, which is I2 here. And this becomes sine theta minus phi. This is from the identity, of course. Then again here, this is cos squared phi plus sine squared phi. We're going to have it 1. All right, I should have written 1. Then there is also this part, cos squared phi plus sine squared phi. We're going to have 1. So 1 plus 1, it's this 2 that you're seeing here. Then here we factored out the 2. Okay, we factored out the 2 here, as you can see. So here we factored out the 2. And we know that cos theta cos phi plus sine theta sine phi is coming from this identity right here. Cos theta cos phi plus sine theta sine phi is equals to this, which is this that we replace here, and we have the 2 that will be factored out from here, which is this 2. Then this 2 is coming from the addition of this cos squared theta plus sine squared theta, which is 1, and cos squared phi plus sine squared phi, which is 1. So that is giving us 2. So from here we see that 1 minus 1 here will give us that will give us, what's that? Will give us 0. 1 minus 1 is going to give us 0. Okay, let me just pull out. Yeah, so 1 minus 1 there will give us 0, meaning that we won't have this part. We're going to remain with 2i sine theta minus phi on the top here. Okay, then at the bottom we have 2. We factor out the 2, that's why you're seeing the 2 and the 2 cancel out there. And inside here we remain with 1 plus cos theta minus phi, as you can see. So the 2 and the 2 there will cancel out. Then we're going to remain with that. Then what we can do here is this. We are going to change this that is inside here. All right, this is a theta minus phi. Okay, so theta minus phi can be written as theta over 2 plus theta over 2. What is half plus half? This will give us theta. All right, so theta over 2 plus and this. And we do the same for phi. We say negative phi over 2 minus phi over 2. What is negative half plus negative half? That will be negative 1. So this will also give us this. So what we can do from here is we can group those with different terms. Theta and phi, we make theta over 2 minus phi over 2. We do the same for those that we introduced, theta and phi. We put them like that. Then from there we replace we replace it inside here. We're going to have this here. Okay, and you see that this and this are the same. Can you see that they are the same? So we can let this and this be equal to some variable we are going to call m. Let me just put it there. Okay, I hope you are able to see that. All right, so we can let this and this be equal to some variable m. So m is equals to theta minus phi over 2. Okay, we do the same at the bottom where there is a phi, theta minus phi, we replace with this, and there is a plus 1 there, which is this plus 1 that we are getting here. So now from here, what we do is we know that this is m, so we can replace that with the m. So this is the m that you're seeing here, and this is m. You can replace the m there, which is just the same as this m here. You see that? Then we have 1, which is this one that is here. Then we have plus, which is this plus. Then cos, which is this cos. Then this is m, which is this m, and that is m, which is that m. Then from here, we are going to use the property of expanding the sign. So this is sine m cos m, which is this identity from identities, sine m cos m, plus, when there's a plus, it's also plus, cos m sine m, which is this again. We do the same thing at the bottom. We have 1 plus, which is 1 plus. This is cos m cos m. Remember the identity. Same applies to sine m, which is this that you are having right there. So we're just using the identity to expand that. Okay, let me see, where am I? Okay. All right. So yeah, so the expansion using identities, this expanding this using identities, we have that, and this using identities, we have that. We have cos m times cos m, which is cos squared m, you're going to have there, minus sine m, which is sine squared m. The bottom part will be this, the numerator will be that. So we know that cos squared m minus sine squared m, this, which is this part, can be written as cos m plus m, which is equals to cos 2m. Okay, which is cos 2m there. And if we replace this with that, we're going to have 1 plus cos 2m. Then the top part, we have that. We can introduce half on top, which is over 2. But what we do at the top, we also do at the bottom. So over 2 over 2. Now this is an identity that you should know, which is cos squared m. Then the top part, which is this. And we see that the halves will cancel out. This 2 and that 2 will cancel out, and on top here we're just going to remain with this. Then this is an identity, which is this. Then this cos m can cancel with one of that, so we're going to remain with sine m over cos m, which is equals to tan m. Now what is m? Well, let me just put right here. Which is tan m. Now what is m? Remember our m? This is our m. So m is theta minus phi over 2. So let's just put that there. So this is equals to I tan theta minus phi over 2. And that is how you prove. So we say hence proved. All right, so have a good day. So yeah, so wherever you have questions, you can hit me in the comment box. Remember to like and subscribe to the channel. Have a good one.